Howdy folks. Today we are going to take a deep dive into functions. And I know there's been a little bit of confusion about functions. Why do we use certain functions over others? Why do we define them certain ways? So hopefully we're going to answer those questions today. So to start off, someone in class showed me this handy little shortcut. If you just do an exclamation mark, click on that, it makes a fully fledged document for you. So that's pretty cool. So I'm just going to put this functions test. You notice also it's got this the viewport meta tag that's already in there, along with the char set and some compatibility stuff, which is pretty neat. So if we load that up, we get that. So I'm not going to do much HTML here, but since we're doing it in the browser, I do need this kind of structure in order to actually run the code. So, to start off, what is a function? Well, a function is a chunk of code that can be repeated multiple times. Why we want to do this? Well, let's say I wanted to say hello 100 times in the console. I could say console log hello. Actually, this maybe isn't a good example because you can do this with a loop. But yeah. Okay, let's say I wanted to create an object 100 times. So I want, let's see, objects equals empty array, objects.push, and then I'm going to create an array with name Bob1, age 1, well, let's put ID 1. And I want to do this 100 times. So I could paste, 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 paste. A lot of pasting. And if I console log objects, and we run this, you can see I've got 6 objects. They all have the same name. If I want to change the name, I have to go through Bob2, Bob4, etc. Change the ID. Okay. I don't want to do that 100 times. That's a lot of code. Now, I could put that in a for loop. So I could put for, equals 0, I less than 6, I plus plus. Remember, this will run 6 times from 0 to 5. Then I could put this in here. I could say name Bob plus I. ID is I. If I get rid of all this code, has pretty much the same effect. So I could set this to be 100. And there we go. We've got 100 Bobs. It's a lot of Bobs. The important thing about this, though, is let's say I want to do, this is some complicated thing where I've got age is going to be whether or not I divided by 2 is equal 0. Let's actually do this is even, and then I want to do some complicated stuff in here, and I want to say, okay, var is even equals this, and then if is age equals 10, if is even age equals 32, make this 22, and then age. Okay, so now again I've got these alternating ages. I could make this maybe even a little more complicated, do some more complicated stuff, but now let's say later on in my program, 1,000 lines later, I need to create more objects. So I could copy this entire thing, say, okay, we're going to create another 100 objects. We're going to go from 100 to 200. Actually, let's make this to 50. And then the next will be 50 to 100. Okay. That's cool. Oh, we need to put this down here too, because we have to console log after we make all the changes. Okay, no difference there. That's great. And then I decide, okay, well, I don't want the age to be based on the even. I want it to be based on like where it is the remainder divided by 10. So we actually end up saying var age equals 20 plus the remainder of 10. Okay, I do that. I run that and I say, okay, 20 all the way up to 29, blah, blah, blah. And then it gets down to here and I realize, oh, I forgot to change this code. And so I scroll through 1,000 lines of my program, and then I get down here, and I think, okay, I know I need to change the age code. I forgot what I need to change it to. So I scroll all the way back up 1,000 lines. Okay, grab this age code, scroll all the way down 1,000 lines. Cool. Done. That'll work. And then later on, maybe a couple months later, I decide I want to actually break this up a little bit. So this one is only going to be the first 25 users. This will be from 25 to 75. And then we've got actually 4,000 lines. If you have 4,000 lines in one file, you have a problem, but just for an example. Okay, so I grab this function, I put this here. Okay, this is going to be from 75 to 100. All right, there we go. We still have 100 bobs. Cool. And then I decide to change the age again, the age formula. Now I have to remember that there's 3 different places in my code. I could do a find replace, but what if at some point I change this to new age and did that? The code still works fine, but a find replace won't work anymore. I can specifically look for this formula, but maybe down here I declared as a constant. Start age equals 20, and down here I said start age. Well, now I can't find this string anymore. So this is actually a pretty common problem if you haven't structured your code correctly, because now I've got 3 places in my code quite far apart that do roughly the same thing. Again, this code isn't structured too well, but that's kind of what we're going to improve upon. This is where a function becomes really useful, because a function is a set of repeatable code that you can call from anywhere. So instead of all this stuff, I could make a function. Function, create object. And then I'll put a name, ID, and age. And then objects.push. I'm actually just going to grab this here. Name, ID, and age. So this is how you define a function. It starts with the keyword, at least for now, it starts with the keyword function. That tells the browser, hey, we're defining a function here. This is going to be a function definition. We're not calling it. We're not doing anything with it. Because if we let this off, JavaScript could get here and it would say, oh, I'm calling a function called createName. And then it would say, okay, here are the parameters to createName. And then it would get to this parenthesis, and you can see now it says, hey, I'm expecting a semicolon here. Because it's saying, why are you opening a block? This is a function call. We don't open blocks at the end of function calls. But as soon as I say function, it says, oh, I know this is a function creation, which means I'm expecting this curly brace at the end of it. Parameters here, you do not give them a type. This is kind of equivalent of var. So these are all variable definitions. However, because the browser knows that this is actually parameter list, it doesn't need var. Because it knows specifically that these have to be variables. There's nothing else they could possibly be. Those are all inside these parentheses like this. You might notice JavaScript does this a lot with parentheses. It uses these to kind of indicate data that belongs to whatever came before it. So in this case, this data, these parameters belong to this function declaration. We then open a block with the curly brace, similar to how we do it with an if, similar to how we do it with a for loop, while loop, etc. Again, very common pattern. The code within these, and you can see VS Code actually knows how to mark these. If you just click on one of them, it actually puts the other one in a rectangle. This is the code that actually gets run when this object runs. So you can do anything. You can console log. Whoops. Create an object with ID like that. Any code, just like an if block, just like a for loop, can have stuff in it. With one caveat, if you declare a var inside of a for loop like this, or an if statement, JavaScript will hoist that variable. So at this point, age, I believe, is available outside this for loop. That is not the case for functions. They keep their own scope. Variables are function scoped. So any variable at the top here, so like let objects, which actually I'm realizing should be var, this is available to everything. But if I create a var inside this function, it will not be available outside of it. I'm actually going to get rid of this console log. Okay, so now that we've done this, we've got our objects pushed. You notice we've made this a little more generic. This is no longer doing Bob plus I because we don't have access to I in here. And we might want to call it something other than Bob. So what we do in here, actually for age, that was the important part. We're actually going to pull this in here too, and we're going to make this not a parameter. We're just going to make this a function of the ID because it's a function of I at this point. So if that doesn't make sense to you, basically I took this. I, in this case, is acting as the ID. So I just copied this code in here. It's the same exact thing, except I'm using ID instead of I, because I we don't have in this scope. So now all I have to do in these for loops is call this function. Create object, Bob plus I, that's the name, and I. This, you know, this is very similar. We have the parentheses, we have a comma. This, because this is the first argument, matches up to here. This is the second argument and matches up to the second parameter. And now I can just get rid of this. And if I run this, I still have those first 25 bobs. 1,000 lines later, I can just copy this, and it's exactly the same code. And now I've got all these other bobs too. Go down here, get rid of this. I've still got my 100 bobs. And now if I want to change this ID, so let's say I want to change this to 25 or 30, I just change this one line. And now you see it works everywhere. Because this same code is being called in all three places, but I didn't have to change it in three places. So this is the value of a function. A function is used for when you have, generally the rule is if you're repeating something marginally complex more than twice, you probably want to put it in a function. As you can see here, we did it once, we did it twice. Not the biggest deal. Let's get rid of this. But the time we did it the third time is when we wanted to generally put that in a function, because otherwise it gets a little confusing. So now let's say we want to do this a fourth time. So we put another 500 lines in our code. And we say, okay, well, let's change this one from 75 to 90. And this one from 90 to 100. Okay? This is literally all we have to do. And if I pull this in, we still have our 100 bobs. They're still in there. And all I have to do is call create object because we took all the complexities of that code and we pushed it here. Now, the next thing to talk about is the closure. This is really important for a lot of reasons. When you define a function, it has access to any variables that are defined in its scope it was defined in. So this create object function has access to objects here, simply because objects was defined at this point, and then the function was defined, which means I have access to it right here. That's not how a lot of other languages work. So if you do something in C++, for instance, that's not necessarily going to be the case, or at least it wasn't when I wrote C++. Same thing with PHP or Python. You have to explicitly let them know what variables you want inner functions to access. This will become important later on. I'll go into this. So functions are pretty useful. You can declare a function. You don't have to have parameters. If you don't want parameters, like if you had a function print hello, you just do it like this. It still needs these. If you leave them out, it gets confused and it says, hey, I was expecting this. That's just how JavaScript's set up. I don't know if there's any particular technical reason why that's the case. And then you can console log hello. Actually, let me move this down. I'm gonna comment these out for now because I don't want to necessarily deal with them. Put this down here. And if I call this print hello, which if you call it and it takes no arguments, you also do with parenthesis, end parenthesis, and what's inside of them is nothing. It's empty. We call it the empty arguments. There's no arguments. There's no parameters. And if we run this, you can see, why did it not like the $sign? Oh, because I put a $sign here. I don't know if you noticed that. When I typed the I was typing too fast and I put a $sign here and it got confused. There we go. Hello. Functions can also return values. So there's two types of return. Let's say we have a print greeting, and then we have a proper flag. So if proper, we want to have a different greeting. We want to say console.log salutations, because that's the proper greeting. Print greeting with false. So if we do false, we still get our hello. If we print true, well, now we get both. We don't want that, because if we're giving someone a proper greeting, we don't want to say salutations and then immediately hello afterwards, because they're going to be confused. So what we can do is inside this if block, we can say return. Now what this return does is it says as soon as you get here, immediately exit the function. Now normally you run through the whole block of code, this block, you get down to here, you get down to this last console log, and then you exit the function. You return back to this line. If I say return, I will get to line 46, 47, 48, 49, and then it'll skip out of the function and come back to 54, even though normally it would hit 51. So run that, you can see. And if I put a breakpoint on this, you can kind of see how that works. So first we go into print greeting. This little button here, the down arrow says step into the function call. If you don't do that and you say step over, it'll just run the function for you immediately and then move the breakpoint or the debugger to the next line, which would basically end the thing. If I step into it, you can see the first thing I've done. Also, it says proper is true. So the first thing it does, I step over. It goes into here, salutations. It hits the return, and then it's done. If I didn't have that return there, so I had that commented out, I step in, step over, and it hits hello, because it didn't return. So that's basically what the return does. The return can also send a value. So if I wanted, instead of print greeting, maybe I want to just return the greeting, I can actually say return salutations or return hello. And then in this case, I would say console.log get greeting true. And you can see it does the same thing, but now it's returning the string and I'm console logging the string that it returned. Another way that's a little confusing, greeting equals get greeting, like that. And if I said false, of course, it would return hello. The default return, if you don't return anything, is undefined. So you can see I'm returning nothing. It's not hitting this if block because I passed false. So it will get to line 50, returns, greeting then gets the value of this function, which is nothing because I'm not returning anything. So that's returns. You can return anything. So you can return not just a string, you can return a number. You could return a Boolean. You can return an object. These quotes don't need to be here. Yeah. So anything, any valid value for anything you can return out of here. So let's move on a little bit. So that was returns. The next thing, let's see, I did the $sign again. Maybe it's doing it automatically. The next thing that we should look at is methods. And the difference between a function and a method is that a method is what we call an anonymous function. It doesn't have a name. And what that looks like is, let's see, to grab our get greetings here, if I wanted to make this an anonymous function, I would declare a variable like this. Now, what's the difference here? Well, one of these is a function. The other one of these defines a method, which has no name, and assigns it to the variable getGreeting. So let me actually show you what that looks like with something a little simpler. Function 1. I'm just going to make an empty function for this. So if I print these both, so log 1. The first one of these is a function named hello1. The second one of these is a variable named hello2 that is assigned to an anonymous function. So if I run this, you can see even the browser treats them differently. It looks at this function, it says, oh yeah, this is a function called hello1. It knows they're both functions, that's why the little f is there. Takes no parameters, has no body. The second one, it says, well, this is an anonymous function. This has no name. And also it has no parameters and no body. So if I was to add a parameter in there, you can see it changes. So the browser recognizes there's a difference between them. And that's kind of, a little important, because if I wanted to say var hello3 equals hello1, I can also do this. Hello3. And you can see hello3, despite being a variable, is still a pointer to the hello1 function. It's just, hey, this is hello1. This is how it works. Why do we care about this? Why do we want to do something like this? Why would this ever be at all useful? Well, there's a couple of reasons that this might be useful. One of them is, let's say that we do have an object, and we want that object to be able to do something special based on its environment. So if we go function create, I'm going to bring back our create object again. Now what I want to do is I want to get a random number times 100 and then math.floor. So what this does is, as you might remember, this generates a random number between 0 and 100. Right now, if I say create object console.log random and run this, it says, hey, I don't know what you mean. Random's not defined here because random is scoped to this function. This variable and this value only exists in the context of this function. So let's say I return an object. I'm just going to return an empty object for now. And I say object equals create object. Can I say object.random? No, it's not there. It doesn't exist, but I do have the object. So let's say that I want my object to do something different depending on the random number. Right? Show random. So this is a variable or a key, right, which is kind of the same thing. And this is an anonymous function or a method. This method, because we can basically do anything for the value of an object, as we learned before, we can put an anonymous function as the value of a key on the object. So now I can call show random. I'm not calling it actually because I'm not doing the parentheses. If I just print show random, you can see, oops, it's an anonymous function. And because of the closure, so if I call this, doesn't do anything. It returns undefined. Because of the closure, this function was created in this scope, in the scope of this function, which means that it has access to the random variable here. And nothing else ever will. So as soon as this object gets returned out of here, as soon as we hit line 67, this variable only exists now as a member of this function's closure. Nothing else can access it anymore. Nothing else at all. So what I can do then is I can actually return random. And there it is. And if I hit it a couple more times, you see it's a new number. But this is the only place that I can access this variable anymore, because as soon as this function ends, the variable technically goes out of scope, but functions hold on to their closures. This variable will not go away until the function goes away. So as long as I have this access, this is here. Now, you might ask yourself, well, why don't we just declare a function here? Function get random. And then I pass it in here, get random, and then this returns random. It does work. And that's completely fine, except this looks kind of awkward. And if I'm going down here and maybe there's like 3 lines of code, which is not completely out of the picture, I have to look and see where this is. That's one issue. The other issue is that it's just not completely kosher to put functions inside of functions, because it gets a little confusing. You kind of wonder, okay, this is a function. What scope is it in? Can I even access it out here? I can't, but it's declared as a function. So it just gets to be a little weird. And so that's the main reason that we have these anonymous functions. Oops. Is because sometimes we just want to declare a function and we don't want to have to come up with a whole name for it. Right there we had get random, right? But what if it's something that we don't want to come up with a name? Maybe we've already declared get random somewhere else, and so we call it get random 2. No, we don't have to. We just declare it as an anonymous function. We don't give it a name. And the main reason for it is because we're never calling this function inside create object. So if I had function get random, and then I had return random, I could actually call this inside of here. So I could say var random 2 get random. And then what would I do here? If I wanted to do something else, and I wanted to maybe return random plus 1. Do I declare a new function, and I call it function get random plus 1, and I return random plus 1? No. That's kind of confusing, especially if I want to do that 10 different times. Maybe I want a bunch of different randoms, and maybe I want to have random plus 2, random plus 3, random plus infinity. I wouldn't want to declare a bunch of different functions as named functions in here just because I'm not using them except as a return value for this object. And so they're not really getting me anything to have this name attached to them because I don't care what they're called. So instead, I can return random. And then I'll just grab another one here. Show random plus 1, and you notice I'm putting the name here, but that's okay because that's the key. That's a key on the object. So I'm actually going to use this later on. So if I go here, there it is. Now, this may not be the best example of this. We actually get into this a lot more when we're dealing with React, because React has a ton of functions everywhere. And if you're declaring 15, 25 functions, you don't necessarily want to have to declare a bunch of named functions for those. So you want to have something that's like this. So yeah, up to the point where we are right now, that's pretty much as far as we've gone with functions. So there's one other thing that I want to show you that we can do with functions, and that is pass them as properties or as arguments to objects or to other functions. And I think we've gone over this a little bit with a filter. So if you have, or maybe not. So if you have a list, list equals A, B, oops, that's not right. Let's just do numbers. You can say list.filter. Right, and then JavaScript kind of figures out, oops, what does it not like about that? Array.filter. Oh, sorry, sort, not filter. And JavaScript kind of figures out what you want to do with that. It does it wrong, though. So you can see it's actually doing this by, not by numeric, but by alphabetical, because 128 is definitely greater than that. So let's say that we want to actually change the way that this list gets sorted. Well, you can pass a function into it. And what this function takes as parameters are the first, basically the list uses some sorting algorithm. I know a couple, but none of them are very efficient. So JavaScript uses an efficient sorting algorithm, but it basically needs you to tell it which one of these should come first. We usually use A and B rather than first and second because that can be a little confusing. But JavaScript wants to know, hey, should A come first or should B come first, or does it not matter? The way it does that is it wants you to return -1 if A should come first, 1 if B should come first, and 0 if it doesn't matter. So what I'm going to do is if A less than B, return -1, else if B less than A, return 1, otherwise return 0. And now you notice if we sort that 125 moves to the end. So this is an example of where we just throw a function here. We could make a function sort numerically that has the same exact code in it. But unless we're going to use this exact sort a dozen different times all over the place, it's more useful to just throw it in here. The other reason this could become useful is what if these are objects. So if this is an object with ID 1 and ID, whoops, I'm not closing these, and ID, I'm going to make these a little bit easier to read here. ID 125, ID like this. In that case, list.sort definitely not going to work. Sort numeric's not going to work. We probably want something specific to this object type. So in that case, we could just actually change this to a.id, b.id. And you notice that the power of the function here is because not only are we not having to, we're having a single body of code that's running multiple times. It's not just going to run 5 times because the list will compare these in a lot of different ways. But also because we made it an anonymous here, we don't need to give it a name really. So maybe this data is just transient. We just kind of made up this data format just for some function we're working on. We don't have to declare a named function specifically for dealing with this data. We just throw an anonymous function because it's kind of almost like a throwaway. We're never going to use this code again once we get past line 90. So why would we give it a name? And you can see if we do this, it again orders it. So that's kind of how you do functions. You can also return functions as from functions. So you can get something, let's see, that kind of looks like this. Let's say we do function get add function. So we return an anonymous function, which takes in 2 parameters, A and B, and then we return A plus B. Okay, so then var add function equals get add function. So what is happening here? Well, we're calling get add function. Get add function, as part of its return value, it defines a function here, an anonymous function, and returns that, which means add function becomes this function. And then, whoops, .log add function 5 and 1. And if we run that, nope, we get 6. This gets a little more complicated because we don't actually have to put this in a variable. We can just console.log get add function, parentheses, and then another set of parentheses. And if we do that, it also gives us 6. You may see this occasionally. It's kind of a little bit of a bad practice because it's very confusing, but what we're basically doing is we're calling this method. It returns a function. We're immediately after calling that function. So the browser gets past this set of parentheses, says, okay, now I have this anonymous function. Oh, another set of parentheses. I must need to call that function on these 2 parameters. And so these 2 lines of code are actually the equivalent. And then it passes that result into another function. So yeah, that's functions. Bit of a deep dive into them, but hopefully it gave you a little bit of knowledge into how this stuff is set up and why we do it. And yeah, I'll see you in class.